Well, in this video I'm going to show how I did convert SDRs, different SDRs, in software-based spectrum analyzer with tracking generator, and even VNA using two devices. And the devices can be from Analysers that are compatible with the software. It's called Satsagen, and it converts SDR compatibles in all that tools that I just said, with a frequency, in my case, using the analog device based SDRs in AD 9361 or 9363 chip, up to from 70 megahertz to 6 gigahertz in fundamental, but can go as high as 12 gigahertz in or 8 gigahertz in harmonics, obviously losing a lot of dynamic range. But obviously when they made the software, they use generic data tables, calibration tables that they used from different devices, and they made like an average or something like that. And even working, if you get a spectrum analyzer, pues you can improve that calibration tables, and at the end it's not so far as to one of these for personal use. No, obviously not in professional use, but yeah, they can. You get a 6 gigahertz VNA, spectrum analyzer, tracking generator, and generator all in once, so or in two devices, and you can do it with one device like this. With one device you cannot do VNA, but you can do the rest: a spectrum analyzer, tracking generator, and generator up to 6 gigahertz. But with one, because there is internal crosstalking, the dynamic range fall quite a lot. So if you use one device with two ports, the ports, you can use a transmitter and receiver from different ports, so you win there a little bit of dynamic range. Maybe get worse in other thing a little bit, but in general you win more dynamic range, like 5 to 10 decibels, depend the device, because there is several of these. And if you use two devices on which you use one TX in one and the other device the RX, there is no internal crosstalking. So, and you can, that is the setup that I have now, but you can add a directional coupler, and then you, with two devices, you can make a VNA. Also, you could use external synchronization with a GPS DO or a precise reference, clock reference, but in my case it's doing it by software, because this one have input of clock, but it doesn't, so the computer synchronizes them. I don't know how, but it does. So, and with two, the dynamic range grow close to one spectrum analyzer like this, that is a HP 8595E, is quite decent. It goes up to 6.5 gigahertz. This ones go to 6, even in harmonics more than this one. but you can use the tracking generator, the generator. You can sweep, and you can use it to measure things. Once it's calibrated, you can use to measure things like a sweeper, a synthesizer. Really cheap, and it go to 6 gigahertz that match this. I got a synthesizer, mini circuits that will be a lot better than this one. But yeah, but that devices, I had good luck to get one very cheap. But if you want to buy one of that, it's £4,000, $5,000, something like that. From there up to the price of a car. So with one of these, one is calibrated with the spectrum analyzer, you get the sweeper. So, and what I did is I calibrate the TX with the spectrum analyzer. I sweep to the spectrum analyzer that I know that the data is good. So, and I do it with mass hold, sweeping with the sweeping like this in the. I cannot do it now. I did a couple of videos of that, but I delete them because my English is shit. So I'm making an effort to speak now a little better, but I lose the focus and I start to speak like more shit even. So I delete the videos. So I sweep, and with mass hold I trace the, like if we're a tracking generator, the trace is in a screen, and with the cursors you go measuring point to point. It's a little slow and but once you have it, with this one that is calibrated, you can calibrate the RX port, and once you have one and one, you can calibrate all the rest, and even the other device. With this device you can calibrate this, and in that case is automatic. The software will have here a tool to the tracking generator. Look, I can start the tracking generator, so, and use the tracking generator trace to export it like calibration for the one that is connected. So I can calibrate TX and RX automatically, which is really fine. And obviously, I don't know if you lose a little bit in the process to do it against this one, but once you have it, you can, and you have a good reference, already will be good, maybe not perfect, maybe not as good like this one, but you have a reference and will be constant in all the bandwidth. So, because the calibration file is a file text, if you compare later to calibrate with this one, after calibrate this one with this one, you can compare against this one, and if there is half decibel off, because it's a file test, you can send to ChatGPT and tell her, hey, to all these decibels remove 0.5, because will be constant the error, because they work when you calibrate automatically, they work in a digital environment. So there will be a constant error that will be by the wires, attenuators, DC blockers. So it will work. So, and with two devices, with one it's good to learn, but dynamic range is a little limited. With this one grow a little bit, but with two go quite good. I had connected right now I have the best setting in my case after test. This is the most linear one. Won't be the one that give me more dynamic range, but maybe I can get 10 decibels more of dynamic range with a different setting, raising the gain, but will lose flatness, especially in the end. So maybe you lose half decibels, but in the tracking generator is less important because you can normalize like a real one and make the zero. So we'll make the trace, for example, I will do right now. So I will normalize. The attenuator is in 0. It's a nice attenuator. It's a Aeroflex windshield or something like that. It's 70 decibels in steps of 1, and it goes DC to 6 decibels to 6 gigahertz. Sorry. So you see, it's making the first reading. I have plus 10 decibels because I have power at minus 10. I could get 5 more, and RX is in 20, so the difference is what I'm getting here. I could get maybe 20 or 5 decibels more, maybe 10 in some areas, especially under 4 gigahertz, but I'm looking flatness. So now, do you see? It's making the zero. It's the normalizing like a real spectrum analyzer that has tracking generator. This one doesn't have the option. So we have now a software-based spectrum analyzer with tracking generator that with 6 GHz span in the tracking generator. The option of tracking generator of this one just go up to 2.9 GHz. So if it is not precise, now it's doing a 0. So we're gonna test the dynamic range because I have attenuator of 70. Well, I have other there, very nice as well, of 769. So, but I'm going to use this one. So I know that I won't have 70 decibels at least in 6 gigahertz probably, but over 50 is crazy. If I can make a good linearity in attenuation, even if the fluctuation appears some fluctuation or something like that, it's crazy for what you pay with this. Would be 350 pounds, and you have all a lot. You have VNA generator, spectrum analyzer, and spectrum analyzer with tracking generator. You can measure the noise figure. It's crazy. I don't know why just for all this. I don't know. I touched something. Well, doesn't matter. I go to sorry, 10 decibels. 6 gigahertz is where it's more important for me. I don't know what happened there. Something got loose. Something, probably one wire or something. Doesn't matter. But you see, I'm getting 10 decibels flat. I go button. Sorry for the. I go 30. I have already 10 because I have a 6 dB and a 4 dB attenuator, so they started at 10. The same does the spectrum analyzer. Is to impedance matching. I don't know how that works, but when you do this, you should have, if you can, 10 decibels in pads in attenuator. Fist is better. If you need more dynamic range, you can put like in this one. When it's one only, you can put 3 decibels, 4 decibels on each, and you win 6 or 4 decibels in dynamic range when that are needed when you have only one. In this case, I have 2 ports and I have different in 2 ports. But in this one that I'm using is 10 now. It's 6 and 4. So right now it's minus 30, very linear. You can see minus 30, perfect. Perfect. I can swap this there and we'll give the same measurement. I go to 40. The little VNA start to suffer in 50. And tiny SA, I don't know what dynamic range have. I don't have one because I have this. Obviously this is a lot better. It has no screen, obviously, but it's better, also quite more expensive than tiny SA is nice. I want one. So at 40 we are getting a very linear reading jet. We go to 50. So already at this point 40 will suffer many. You cannot do 40 probably with only one device. Even if it has 2 ports, you will lose at the end. Will make waves maybe of 3 decibels up and down. It's still okay, but for measure antennas and all that, it's just fine. So, but we have now 50 dB in perfect. The music with the previous one is not suffering. 50 dB plus 10 that is in paths already. 60, and it still is perfect. 70. This is the first run that I have with the VNAs with the SDRs calibrated, because I just got this 3 days ago. This is the first thing that I did with it, is calibrate this. They are not perfect because I have there some data attenuator, DC cup. I used all that in the calibration, so maybe I didn't compensate properly. Maybe it's half decibel off. And in 70, it's still valid. You see? But obviously you go 3 dB up, 3 dB down. 1 dB down here and 3 dB up here, and at 6 GHz, and here two. So I would say that normally the specs up to 3 decibels. They say that they are in specs. I have no technical background in all this. I'm just a hobbyist, but usually for me 3 decibels is good. This here is because the mixers in the devices they have some cuts. That cut is normal. It's for the 4000 exactly. It's because it's how they work. They have there like a cut. But we have now 70 dB. 70. This one have 70 or 80. If you remove the attenuator, I don't know. It's crazy this. I'm surprised right now. Oh, I went to the maximum. Oh, yes, I went to the maximum. I cannot go. So I go to 10 in the step 1. I don't know how to make videos on YouTube, and here is suffering more. But to measure antennas, stuff like that, no. Well, obviously it's not usable. 70. I'm going to remove 5 because 80, it has no 80. I'm gonna remove 5, maybe 75. We're gonna see if we have 75. So it's 65 here plus 10, that is yeah. Come on. If it goes 5 dB at the end, we don't give it for good. Well, no, but we can give it for good because only at the end is 5 dB. Well, if you don't need 6 GHz, it's only that in 80. So 75. We put 70. 70 is flat. 70 dB. So, and this is with a tracking generator. So, what I'm going to do is compare with HP. So I have this wire this cable is not very good. They are bad quality. These ones are very good quality, but they are very rigid, and these ones are good quality, but they are very small. So I don't have good wires. I bought a few, but they are fucking expensive. So this is the output, so I need to connect this one here. One sec. All right. Now we have I'm missing something. Alright, sorry. I miss with the wires. I have a wipe in the brain, so I had a stupid error. So doesn't matter. So I'm going to put now in auto bandwidth average off, average on. In 5 is not able to get the sweep, so I'm going to put 2. No, I need to remove the video average because cannot get the signal. It's too fast. I guess, or something like that. Resolution bandwidth is normal, so I put now trace mass hole, and we see and that spikes will appear. It's normal. It's an option that there is connected, activated, that is a calibration, auto calibration of the X. Don't worry because that is normal, that there is some spikes, and you can remove that, but I need to turn off now. So we have here 40. I got to go more faster to 60. We clear más. $60 full span. I remember 70. This one 70, and we are in 60 and this one, and is is ending. I cannot get 70, I think. I think even is suffering in the precision. Marker. Marker. I don't know how to use this very well. I need to clean a little bit the signal. Is reference -10. So amplitude should be 0. Oh no, it's not like that. Amplitude reference don't allow me. I don't know why the reference goes to -10 and don't allow me go to 0. I don't know why. No? No? Don't allow me. It's the first time that I try, so I'm making the video a little long. I don't know. I'm sorry. But so this is -10, -20, 30, 40, 50, 60, 70. No, so we have the same than this one. And I'm going to move to the marker to some point that is already clean. Oh yeah, a decibel, in this case 2, fluctuating, so it's not perfect, the line like this one. So obviously we can go lower. I'm going to change the resolution bandwidth. No, sorry. Resolution bandwidth manual to 1. No. 1 megahertz. No. Oh my god, how is this? It applies straight away. Alright. So if I clean now, display trace clean. Yes, I want dynamic range. So Now we can try go more. And mass hole, trace mass hole. I think it's not getting the signal. No, 75. I'm going to remove 5. Sorry, I need 1, 2, 3, 5. No. Yes. So effectively we can to do 70. Same dynamic range than this one. Yeah? It's unbelievable. After the calibration that I did with the spectrum analyzer. But unbelievable. Flatness is the same, more or less. And this one is unbelievable. You have a fucking lab on 2 devices of this if they are properly calibrated. It's unbelievable. I needed to find the combination because you can put this like transmitter and this receiver, or is this one transmitting and this receiving, and use this port or this one, so they don't behave the same. If I put this like RX and this one like TX, doesn't work so good. There is a quite a strong cut in 4 GHz. In this one is softer. The transmitter is better transmitter, this one than this one. Maybe they are the volumes. I'm going to check the volumes, and I have mini circuits ones, the 6 GHz. I'm going to swap them probably if they are no good. And yes, the flatness is good. So yes, so we have minus 10, 20, 30, 40, 50, 60, 70. 75. No, 74. And all this 75. 75. So we have 5 more in this one than in this one. I'm going to make other try and put 5 less. So mass hole now. We're going to see. So it was 75. 5 more than the SDRs. And yeah, this one is gonna do it as well. Another 5, 80. So 80 dynamic range. It's a long video, sorry. Yes, I'm going to try. I'm gonna clean So 80. I'm going to change the resolution bandwidth to a smaller one. 600 kilohertz. Obviously we'll jump. We're going to see video bandwidth maybe fall as well, but this is too that is too much low, so I'm going to raise. Yeah, there 300 is usable. So but this one also go a lot faster. It's not comparable. So I need to try in this one to do the same settings than this one. But yeah, in full span and highest resolution bandwidth, 70 both. No, 75, 70, and still this one is faster. It's unbelievable. So display trace must hold. So we can go another 5. 1 second. So we got another 5. Very slow. Okay. We're going to say that this one is not enough good because it's a little high in decibels. So alright, so 70, 75, 70, 65, 65, 70. In average, this can get 10 more than this one. So yes, it's impressive. I hope this, if you cannot buy one of these for hobby and you need something more than a tiny SA, you can get this and calibrated with one of these. I don't know, you can ask me, maybe I can do it. Maybe I can sell calibrated ones. I don't know. If you are interested, just leave it in the comments and maybe we can do something. I can make this for you. Maybe. More tests will come. I need to make a VNA with this. This is the option here. So is so you can raise a VNA. Alright, so alright. Thank you for watching.